Welcome to the STA Compact Service Training Program. This section of the training program is designed to give you a general look at the unit so you can become familiar with it before a more in-depth look within it. We will be covering the electrical and mechanical layout of the unit. At the end of this introduction, you should be able to identify the different sections of the unit and what those sections in general are used for. The STA Compact is an automated laboratory piece of equipment designed to diagnose and monitor coagulation abnormalities. The unit's operating system is DOS and capable of performing clotting and chromogenic assays on plasma samples. Two measurement principles are used to make this measurement. Let's look at the front of the unit. The left door gives you access to the floppy drive, circuit boards, and the power supply LEDs. The LEDs show you that the unit power supply and fuses are okay and in working order. If the unit is on, all LEDs should be on. The floppy drive is used for backing up your files, software updates, and allows use of the service disk, which gives you access to the service options. Now let's move on to the right door, which allows you access to the cuvette wheel and the syringe. The syringe is used to pipette sample and reagents into the cuvettes on the measurement block. Replacing the syringe tip is a key maintenance item to ensure accuracy and good precision. The cuvette wheel holds approximately 1,000 cuvettes. The cuvettes are placed into a shuttle by the cuvette loader. The shuttle then moves the cuvette to the measurement block. In addition, this is where you find two micro switches. One micro switch tells the unit when a shuttle is in the loading station, and the other micro switch that a cuvette was loaded into the shuttle. The front plexiglass cover lifts up, allowing you access to the pipetting head, arm 1, and the inside of the unit. The unit will shut down unless the service disk is in the floppy drive or the door safety switch is bypassed. By opening the front cover, you have access to the 3 needles. Needle 1 picks up sample, quality control, calibrators, desorb, and Owen-Cohen buffer only. Needles 2 and 3 pick up reagents. The multi-pipetting board is also being shown so that you are aware of the liquid level detect wires and the LEDs, which are common issues for liquid level detect problems. Recommend you locate them and look at them while in operation at a convenient time. In the back right corner is the temperature regulation board. Also, arm 2 is at the far right. You can see the Z motor here. This Z motor is the same motor that's used for moving the needles up and down. Note, cat piercing units have a different, larger motor because it is a cat piercing motor. You can also see the rubber boot, which is an expendable item. This is also a good view of the measurement block, which is divided into 2 sections. Front 16 sections are incubation wells, which are kept at 37 degrees C. There are 4 measurement wells, and note that the wells are counted from back of the unit to the front. 1 through 16 are incubation wells, 1 through 4 are measurement wells. This is also a good picture of the chronometry analog board for clotting tests and the A to D photometric measurement board for optical measurements. In front of the measurement block sits the waste container for the cuvettes. The cuvettes are disposed of here after the measurement cycle. The cuvette waste drawer rides in and out on a steel guide rail. Below the plexiglass cover there are 2 drawers. The one on the right is the product drawer and is used for reagents, quality control, and calcium chloride. The one on the left is used for samples and Owen-Cohen buffer. Both drawers contain a sample and a reagent display board and a sample and product detection board. They are easily removed by putting 2 fingers under the display board at the front of the unit and lifting up. Most common problem for one spot not to be read is pieces of label blocking the light pass of the detectors. Cleaning will resolve those issues. There are 2 drawer motors in the back which move the drawers in and out. In the back of the reagent drawer, you can see the wash wells for the 3 needles. They should never overflow. They should be able to hold solution. Quality control issue and the number 1 failure for many years with the STA Compact is wash wells overflowing due to the failure of the EV valve or BVs in a wash well. The right side of the unit is divided into compartments. For the most part, each compartment supports different systems within the unit. The left section supports the fluidic system for the 3 needles. From the top down, you have a pipetter assembly, which picks up the reagents and samples for needles number 1, 2, and 3. A little to the right is the block of 3 EV valves, which control which needle is being used. Below that, you've got a Valcor pump, which pushes cleaning agent through the needles for washing. And note, there should never be any air bubbles in the tubing between those assemblies. Bottom of this section is the cooling reservoir bottle, which is used for cooling and heating of the product drawer and the measurement block. This can be filled almost to the top with glycol or water. Water was used for many years and was switched to glycol to prevent unit from freezing during shipments. At the top center section, you have the optical module, which supplies the light for the chromogenic tests. To the right of that, the EV valves for arm number 2, which moves the cuvettes from the shuttle to the wells. Below that, at the bottom center, you have the cleaning solution bottle and the waste bottle. Now to the far right. At the bottom, far right, you have the clean reservoir bottle, which gets its cleaning solution from the large cleaning reservoir, which we mentioned earlier. Right beside the cleaning reservoir bottle is the waste reservoir bottle, which is the far back of the instrument. The cleaning solution bottle should always have solution in it. The waste bottle will have different degrees of waste. Now onto the back of the unit. You have filters. On the top right, you have the connectors for the VGA monitor, the printer, the LIS. Onto the left side. Here you're going to see the fuses on the bottom front, and on the left side you're going to see the power on switch and the 2 main fuses. This is also where the serial number to the instrument is located. That concludes introduction to the operator training session. Thank you very much for your time.